Hey everybody, my name is Noah and this is my principles practice presentation on the restoration of hardwood coniferous wetland swamp for maximizing biodiversity, water movement, and removing excess sediments and nutrients as a natural sink. This natural community is kind of a catch-all term combining several of the 78 different types of land cover across the state of Florida according to the Florida Cooperative Land Cover Map in the figure. As you can see, Florida is chock full with different habitats, which is awesome, but also means there's a lot of gray area in between communities. So, some of the other habitat categories that fall under this umbrella term include mixed wetland hardwoods, mixed hardwood coniferous swamps, alluvial forest, and floodplain swamp. I chose this topic because this type of habitat makes up significant portions of Pensacola, which is where I live, as well as the Escambia River Water Management Area, which is that big brown and purple area with the blue arrow pointing to it. Mixed forest swamp and wetlands like this one are important because of their high biodiversity, fluctuating hydro periods that regulate water movement, and their ability to trap large amounts of sediments, nutrients, and contaminants in what we call riparian retention. And I'll go into more detail on these aspects in just a minute. But as you can see, the Escambia River WMA eventually empties out into Pensacola Bay, which means there are potential downstream estuarine effects from this watershed. Okay, so it's important to first understand why hardwood, coniferous wetlands, and swamps are degraded in the first place, and what specific components have been impacted the most. Going back about 10,000 years, Native American agriculture has been highly associated with rivers and bottomland forests. Cultivation practices were typically small scale and had minimal impact due to mound building that created areas of suitable soil for farming. There was some girdling of trees to clear land, but Native Americans optimized available space by combining plant species, such as beans that would grow vertically up corn stalks. Now, early colonists did not place much value on hardwood wetlands and swamps, mainly because alteration would require strenuous hand labor. However, once the Industrial Revolution was in full swing in the early 1800s, conversion of forests towards agricultural fields rose substantially and was even subsidized by the US government. It's also important to remember that upland habitat modification and management can influence lower elevation ecosystems, which is detailed by the effects of soil erosion in the figure below. In fact, displaced sediment into a catchment remains in many floodplains and swamps to this day. But obviously, dikes and dams can have and had the most significant impact to floodplains and swamps. Both structures retain water to a specific area, with dikes typically preventing flooding or restricting water movement, and dams holding water in a reservoir and occasionally releasing that water when needed. The hydro period for a wetland is the length of time it is saturated or flooded with water, with each case varying by location. Dams can greatly reduce the hydro period with slow releases of water, while dikes may prevent water from entering a floodplain altogether. There is also physical hydrologic disconnect created by dikes and dams, which can confine water to narrow channels downstream and also retain sediments upstream of a dam. This in turn produces a sediment starved floodplain. And in this photo, you can see the water being dam released to make a few rivers, while most of the floodplain does not experience any flooding. So, this is likely an example of a dam creating a deeper river while also altering the hydro period. Okay, so with that background information in mind, let's go into the restoration of a degraded hardwood coniferous wetland swamp. The first thing to do is determine a nearby reference site with appropriate structure and function. Using the Florida Natural Areas Inventory Guide, there's some really good nearby choices for exemplary floodplain swamps. Number one on their list just happens to be the Escambia River, but there's also Apalachicola River and Choctaw-Hatchie River, which are also in the Florida Panhandle. And I'll be drawing on all three for restoration goals and objectives for this presentation. And if you're really unsure of what kind of site you have due to extensive degradation, matching the soil composition to a known site is a great solution. This website I provided here leads to a UF extension paper that includes a handy table to help you. So the first aspect we are looking at is the restoration that maximizes biodiversity. Bottomland hardwood forest tree planting should be more intensive than extensive, meaning that a smaller area with a higher labor, treatment, and management is a more effective strategy. The primary plant should be seedling oak species, such as overcup oak in flooded areas and swamp chestnut oak in bottomland forest, while bald cypress and tupelo species should be planted heavily as well, preferably with PVC sleeves around their trunks to prevent herbivory, like the one in the center photo below. Interplanted species include ash, elms, planter trees, and red maple. The reason for including interplanted species is that natural regeneration has been shown to be unreliable if parent trees are more than 100 meters away. So that's just something to keep in mind if you find yourself in that situation. And after the trees have matured and you've done it right, lots of bald cypress knees, like the one in the bottom right photo, will dot the landscape, causing many people to trip over them. All right, so practitioners also recommend that restoration of wetlands and swamps aim for planting up to 750 stems per hectare using the intensive planting technique. A couple more considerations for increasing wildlife is making sure that water can adequately flood these swamps and wetlands. Floodplain inundation is a common cue for many fish to initiate spawning, such as the red ear sunfish, largemouth bass, and the alligator gar. Floodplains also provide exceptional foraging areas for the American alligator, as juveniles commonly consume insects and frogs, while adults will also eat terrestrial animals in floodplains, such as snakes, rodents, and even feral hogs. This photo in the middle here is one that a trail camera of mine picked up with an adult alligator venturing into a flooded forest, which was super cool, and I just wanted to include it here. All right, there's also many birds that are selective of which trees they forage on in swamps, such as the yellow-throated warbler, which is highly associated with bald cypress trees. So, with knowledge of the natural history of native swamp animals, restoration that caters to their habits and behavior will increase their presence. Next, we can look at the restoration of water movement. And I think it's probably best we look at smaller scale restorative techniques and move up to larger ones that unfortunately may not even be feasible due to political, societal, and economic complexities. The first is by modifying dam release schedules that can inundate wetlands using during desired time periods, as well as the magnitude of water output. There has been moderate success using this strategy in the Apalachicola River Basin, in which mussels will hopefully rebound with persistent flowing water in streams, which reduces hypoxic conditions that mussels cannot inhabit. Also, deeper water in some streams may also introduce larger fish, such as the Gulf Coast striped bass that requires cooler water as refuge during warm summer months. If restoring a wetland that was used for agriculture, simply plugging ditches surrounding the property can raise the water level naturally. This is typically viewed as cost effective. On a larger scale, reconnecting floodplain channels can be achieved by adding a variety of dikes. One example are notch dikes like the one you see on the right here, where river water still flows downstream, but dikes with spacing along them slows water down and pulls water into low-lying areas. And of course, there is complete dam removal, which solves many problems, including unnatural water flow, but also the physical barrier between biotic exchange. Although dam removal is pretty large scale, this technique has been gaining in popularity and acceptance, as over 2,100 dams have been removed in the United States since 1912. All right, and lastly, we'll go over restoration of wetlands and swamps so that they efficiently provide retention of nutrients, sediments, and contaminants as a natural sink. The first restoration objective is to maintain or increase the floodplain area because size matters. Nutrients, including common excess agricultural runoff ones like nitrogen and phosphorus, along with sediments, have a higher retention rate with a greater riparian buffer zone of wetlands. Secondly, increasing the frequency and duration of water inundation into a floodplain has also shown to have a positive relationship with nutrient retention. However, there is a trade-off with this restoration practice and its desired objectives, as increasing frequency and duration can be manipulated but not necessarily align with natural river fluctuations. Thirdly, where restoration efforts should be prioritized along a river may depend on sedimentation objectives, as lower velocity areas will allow for suspended sediments to settle in wetlands to act as a natural sink and filter them out. In the top right figure, lower velocity for the river is on the inside of the bend, so that's where a greater chance of settling sediments will be. And finally, it's important that the entire floodplain is connected so that it can reach its full potential as a natural sink. A great restoration practice to ensure this happens is by either replacing damaged culverts or sometimes just removing them altogether. And I think we all know what an acceptable and operational culvert looks like. So the photo on the right is a collapsed culvert that is really doing a poor job of connecting water on either side of the road. It's also good to mention just how important vegetation is for pollutants. A lot of benefits from plant matter are indirect as well, including supplying organic matter to soil, modifying water movement, and preventing erosion. Having a healthy soil allows microbes to break down pesticides and wastewater contaminants. So, in conclusion, we detailed quite a few restoration practices and considerations for hardwood coniferous wetlands and swamps. We started with choosing an appropriate reference site, determined what tree species to plant and how many, and also how we need to factor in natural history aspects of animals to match our restoration objectives. We also applied different restoration practices at both small and large scales to influence hydrological features, and then we looked into what restoration techniques can best trap excess nutrients, sediments, and contaminants from the surrounding environment and from the river itself. I recommend you follow this guideline in the order I presented topics and incorporate practices that match your objectives using some of the ones I provided, while also considering the natural behavior of the landscape. All right, so I hope you enjoyed this presentation, and I will end it with my favorite swamp frog, the bird voice tree frog. So here's its call here. All right, and here are my references, and thank you very much.